So we're all swimming in Wi-Fi signals, right? It's what connects our phones, our laptops, our entire smart homes. But what if I told you that invisible network is doing a whole lot more than just carrying your Netflix stream? What if it's actually learning to see?
I know, it sounds like something straight out of a sci-fi movie, but this is real. The radio waves that are filling your home right now, they have this hidden superpower. They're not just, blindly zapping data back and forth. They're actually painting a super detailed, invisible picture of everything around you.
Just think about it for a second. When your router sends out a signal, it's not a laser beam going straight to your phone. No way. It's more like a splash. The signals bounce, they reflect, they bend around every single thing in the room. The walls, your couch, and yep, even you. And every single one of those bounces, it's like a tiny sensor, all of them working together to create the secret map of your space. Okay, so how in the world can a bunch of invisible radio waves actually see? Well, it all comes down to the incredible amount of detail that's hidden inside those signals. All right, so in any room, right, the signals create this, let's call it a stable, predictable pattern. They're just bouncing off the furniture or the walls, things that don't move. But the second something does move, like you walk across the room, that whole pattern gets disturbed. Your movement causes these teeny tiny changes in the paths of those radio waves, and believe it or not, our modern Wi-Fi gear is sensitive enough to pick up on that. Now, the magic key that unlocks this whole superpower is something called channel state information. You'll hear it called CSI. And what's really, really important to get here is that this is not just about signal strength, how many bars you have. No, CSI gives us this incredibly rich, detailed snapshot of the signal's entire journey. It looks at dozens of different frequencies or subchannels, and it captures these tiny, tiny shifts in both its power, that's its amplitude, and its timing, or its phase. And this is just a massive leap from the old way of doing things. We used to use something called received signal strength, or RSS. The best way to think about RSS is it's like trying to see a picture that's made of only one single pixel. You can kind of tell something is there, but that's it. CSI, on the other hand, is like upgrading to a 4K high-resolution image. It sees all the fine-grained, nitty-gritty details of the environment. I love this analogy because it just hits the nail on the head. A sunbeam, right? It's just a single blast of white light. But a rainbow? A rainbow takes that sunbeam and breaks it down into all its different colors, all its different parts. That's exactly what CSI does to a Wi-Fi signal. It splits it open and gives us this whole spectrum of incredibly detailed information. So, you've got all this crazy data. How do you make sense of it? Well, that's where modern AI comes in. You can actually train an algorithm to learn the baseline of a room. The normal, static pattern from the walls and furniture. Then, the AI can just subtract all that background noise. And what's left over? Only the dynamic signals. The ones that are being changed by movement. And that's what makes the system so unbelievably precise. Okay, so that's the how. We've got this science down. Now for the really fun part. What can this tech actually do? Because this is where it stops being just a cool idea and turns into a seriously powerful tool. So, the researchers looking into this have basically broken down the applications into 3 big categories. You've got activity recognition, then object sensing, and finally, localization and tracking. Let's kick things off with activity recognition. Seriously, imagine controlling your entire smart home just by waving your hand. No remote, no yelling at a smart speaker. There are systems, like one called Y-Dance, that can analyze how your hand gestures disturb the Wi-Fi signals. So you could literally swipe through the air to skip a song or flick your wrist to turn up the lights. How cool is that? But this goes way, way beyond just being convenient. For something like elderly care, this technology is an absolute game changer. We're talking about Wi-Fi-based fall detection systems that can hit over 90% accuracy. Think about that. They can monitor for a sudden fall without forcing someone to wear a special necklace or putting cameras all over their home. It offers real safety while, actually preserving their privacy and dignity. And it gets even more detailed, even more fine-grained. This is the part that just blows my mind. There are systems in development that can literally monitor your vital signs while you sleep. They're so sensitive they can detect the tiny movements of your chest rising and falling as you breathe, and even the super subtle motions from your heartbeat. All of this just by analyzing how those little movements affect the Wi-Fi signals around you. No wearables, nothing touching you, just Wi-Fi.
Okay, this all sounds pretty incredible, right? And it is. But, and this is a big but, a technology this powerful comes with some equally powerful challenges and some pretty serious risks that we really have to talk about.
So there are three main hurdles we need to get over. First up, it's super dependent on the environment. What that means is, if you train a system to work perfectly in your living room, it'll be completely useless if you move it to the kitchen. The signal patterns are just totally different. Second, it's data hungry. I mean, these AI models need mountains of high-quality, labeled data to learn properly. But honestly, the biggest hurdle, the one that should make us all pause, is the massive risk to our privacy and security. There's a line from one of the original research papers on this that it really puts the risk into perspective. It says that the very thing that makes Wi-Fi sensing so powerful, the fact that these radio waves go right through walls, is the exact same thing that makes it a terrifyingly good tool for surveillance.
And look, this isn't just a what-if scenario. Researchers have already built systems to prove how dangerous this can be. There's a system called WindTalker that can figure out your smartphone password just by analyzing the tiny motions your hands make as you type. Another one, Why Here, can actually reconstruct a conversation just by sensing the mouth movements of someone talking in another room. The implications of that are, to put it mildly, pretty chilling. So where do we go from here? We've got this immense potential on one hand and these really profound risks on the other. What does the future of this kind of sensing actually look like? Well, the roadmap for this tech seems to be evolving in clear steps. It all started with simple detection, right? Just asking, is a person in the room? Then it moved on to localization. Okay, where is that person? From there, we get to recognition. So what is that person doing? But the final frontier, the really complex part, is genuine understanding.
The ultimate goal here is something called context sensing. It's not enough to just recognize an action. The system needs to understand the context and the intent behind it. So, the system of the future won't just see a person is lying down. It'll be smart enough to figure out, are they sleeping peacefully? Are they just chilling out reading a book? Or have they fallen and are they in medical distress? Making that leap from just recognizing to truly understanding, that's the holy grail of this entire field.
And that brings us to one last big thought to leave you with. With every single router we plug in, we are, without even realizing it, building the world's largest and most intimate sensor network. It's a network that's silently watching from inside every home, every office, every coffee shop. The tech is moving forward at an absolutely breakneck speed. So the real question we have to ask ourselves is, are we ready for what it's going to see?